Okay, thank you. My name's Seth Knox. As Bernard mentioned, I'm VP of Products, so I work with developing the products as well as writing a lot of those white papers and reference architectures with my team. So one of the things I wanted to touch on first is that from the server virtualization perspective, we're going to touch on desktop and server here. I'll give you an introduction to the platform, and then Chetan will take you into a deep dive kind of tech discussion where you can ask all the detailed questions. One of the things that we're seeing driving customers is that they're adopting server virtualization. Latest numbers are something like 74% of total servers are virtualized. That is driving tremendous storage capacity and performance increase in demand. So, depending on whose numbers you look at, it's something like 40% per year increase in capacity, which means that you're actually doubling your storage capacity in your data center every 2 years, which is a tremendous pace to keep up with. Now, one of the reasons for this inefficiency is that we have, in physical data centers, have a mapping of an application to a physical server to a physical piece of storage of some class, tier 1, tier 2, tier 3, whatever the type of storage. Now, for the last 10 years, we've been breaking down those silos on the server side of the equation, but storage has remained very siloed and physical. So what we're talking about doing now is moving the existing SAN, NAS, and DAS of different types and different tiers into pools of higher performance, accelerated, and optimized storage. So the term software-defined storage, a lot of you have written about this, software-defined everything, cloud washing. It's an overused term, we acknowledge that. But I wanted to set some principles of what we think it means in terms of definition and what the value is before we get too far down this road. So first of all is really the ability to abstract it, the physical,
what's going on,
the data plane, moving the data between all the different pieces of underlying hardware. The second one here is really the control plane, unifying management, being able to create a volume which is made up of multiple underlying pieces of hardware, have data services on top of that pooled and aggregated storage. The third one is really being able to do it across different types. This isn't only for flash, this isn't only for file, this isn't only for block. This has to be able to span the different types and tiers of storage across the data center. Optimization is a big part of it. We want to get beyond just the sum of the underlying parts in a pool and start doing intelligent things across the whole pool to minimize the amount of data that you have to store. And we'll talk a lot, that's our history. A lot of our DNA is built around this optimization piece, and we've been doing it on the desktop side for quite a while. So we'll talk a little bit about what we do. And then the last one is, potentially the most important one, is being able to accelerate the provisioning, tie in with cloud, look at orchestration systems, and automate a lot of the entire stack in software instead of having to go rack or provision new hardware or new volumes or LUNs. Okay, so I'm going to give you the introduction to the platform. Chetan is going to go much deeper into the underlying components, but let me start off by introducing this concept of in-memory storage technology. So what we're doing here is we're inserting a layer at the hypervisor level that is leveraging server memory as a tier or as primary storage. Now, not a tier in the traditional sense, but as a piece of storage that you can leverage and then do optimizations on top of that. Now, some people might talk about, oh, well, if you're introducing a guest and an extra hop, you're reducing performance. But by doing it this way, we're actually accelerating what a physical storage would be able to do, because we're serving a lot of the I/O, processing a lot of the I/O, and handling things out of the server's memory, which is closer to the application. So that's a key kind of premise of our entire platform. Now, what happens is the VMs see us as the data store, but that's presented through the hypervisor, so it's very transparent. Then the I/O passes through us. There's less I/O to go onto the physical storage because of all of the inline deduplication and processing of I/O that we do. There's less I/O traffic. There's less network traffic. So you're handling and eliminating a lot of the problems with virtualized environments and how much storage they consume at the server or compute layer before it reaches whatever the underlying physical storage media is. So now when you do this across the whole data center and you're pooling, you're presenting a single kind of interface. You can have multiple volumes, but you're able to take existing SAN, NAS, and DAS of different types and then expose them and have this consistent optimization across the whole platform.
So you're using RAM. Is this a read cache, write cache? Is it actually a tier? I know you said tier before, but...
So yeah, tier is kind of a misleading term and has a lot of baggage. So it's not caching in the traditional sense. There's actually a series of optimizations. So all of these things, coalescing, compression, I/O processing, handling a lot of the I/O that's duplicate in memory, and then inline deduplication, doing on the fly. We know that that is a duplicate block that is already on the back-end storage.
Okay.
Yeah, go ahead.
So you're doing all that in host memory?
Yes.
Now, what about issues of data integrity, write back, and things like that? I mean, it sounds like there's a potential for...
Yeah, so we're actually, Chetan's going to get into that in detail in his section. Yeah, so hold that question, make sure we come back to you and remind us if we don't answer it once we get through Chetan's.
Is it a driver in the hypervisor or is it a VM?
No, it's a guest VM. Okay. It doesn't change the hypervisor, it doesn't change the application. So you can actually insert it into an existing running environment, storage vMotion things onto it, and not even reboot your VMs. So it's extremely transparent. It's designed, we've been doing that on the VDI side for a long time. It's designed to be able to be inserted into an existing environment without installing drivers, without upgrading your hypervisor, without any of that kind of baggage.
Does the hypervisor see it as a data store, like NFS?
Yes, it looks like you go to the data stores tab and there's the data store, whatever you called it, right? It knows no different.
Okay.
Just turns around and presents a new NFS data store. Yeah.
Okay. Another part of this that goes along with that provisioning aspect of our software-defined storage slide there is that we've built the whole management system. All of our UI is built on REST APIs that are all exposed to whatever orchestration system you want. So we're really embracing that idea of we don't need to be the pane of glass for storage. We tie in and people write scripting and automation and use tools like OpenStack and VCAC and CloudStack and other orchestration tools that are already in place. We've been doing this for a long time, but not formalized it on the desktop side. We decided to do that from scratch when we released USX. Okay, so one of the benefits that you get here is that we also can tune and create storage volumes out of these pools that have specific attributes from a performance, capacity, and availability standpoint. So you can dial up or dial down, deliver the exact amount of high availability, resiliency that you need for an application.
So I'm using my existing storage here. I'm not ripping and replacing or going
existing storage. Almost all of our beta customers, they're like inserting it into an existing environment. They're not even consuming the whole SAN or NAS. They're carving out a little bit of it for us. We're pooling and aggregating it, and now they have a new type of storage volume that they can use that's higher performance and is more efficient than what the underlying physical storage does.
You're pulling and aggregating across everything, DAS, NAS, SAN, everything.
Yes, yes. Anything that works with your hypervisor can be pooled and aggregated.
Okay.
Okay.
And then are you using memory to accelerate?
Yes, memory can either be used to accelerate or it can be used as the primary storage in a model that we call in-memory. So that is, the concept of an in-memory database has been around for a long time, but nobody's ever done an in-memory storage volume that could be used for anything, across the board, right? That's kind of the new.
How much RAM do you take in your virtual machine?
The amount of RAM you take depends on how you use it. So if you're using it to accelerate SAN, it's a very small amount of RAM. We can give some examples. I think when Chetan goes through on, an amount of RAM, maybe it's 20% of the underlying post-optimized block in a case where you're doing a hybrid type approach where you're accelerating SAN.
And for acceleration purposes, are you reordering things so that you're writing sequentially to?
So that's one of the optimizations. There's many though. Let's wait for Chetan to go through those because he's the expert on that. He developed it, so he'll give you much better answers than I do, and you'll be able to get more out of him about how it actually works under the covers. Okay, so one of the important concepts here is that logically we're sitting in line between the VMs running on the hypervisor and the physical storage media, and it can connect via any protocol, right? So you have your pre-optimized storage traffic with the blue on the left, and then you have all of those optimizations that happen, and then you have less I/O and less actual blocks or files to store at the end of the day. So this is the data reduction part of it is something that's not a part of all software-defined storage products. Many of them are just for managing and pooling, but the key here is that we're actually reducing the total amount that goes over the network and actually lands on the physical storage. Okay, let me talk about how we apply, that's kind of the overall platform. Let me talk about how we apply it in a desktop virtualization scenario, and then we'll get into Atlantis ILIO USX on the server example. So in desktop virtualization, user experience is everything. There's a million failed VDI deployments because users did not get a desktop that was equal to their physical PC performance. It's very difficult to deploy certain things like stateless and operationalize all of that. We add a lot of value in terms of provisioning and cloning very quickly, as well as reducing the total cost per desktop while increasing performance, which is the key. And then a lot of the VDI deployments, since they've gone through some failed ones, are very risk averse. So we focus a lot on reducing risk, automating things, eliminating errors, and so forth. So some of the things that are unique about how we do desktop virtualization, we'll do a demo in a little bit, and we have a demo environment that we actually give out desktops running in memory that you can try if you want to run it for a couple of weeks. But you can get faster than MacBook Air disk speed or performance in a VDI desktop. We will demo that shortly at the end of this. The CapEx cost of the infrastructure on a stateless virtual machine with no storage, just running in memory, can be under $200, including our license, the storage, and the server. That is a magic number that can get you to equal or around the same cost as a physical PC with the whole stack. Persistent VDI, which again is common in the largest of deployments, is something that you can achieve with under $300 in storage and 300 IOPS per desktop. Okay, I mentioned risk. This is really critical. Automation of all of these processes, operationalization is critical to successful VDI deployments, as well as XenApp. And then migration. A lot of people start off stateless and then decide, oh, I can't really do stateless. I need to go persistent, or vice versa. Or people start out persistent and then decide that their strategy over time is to move to stateless. We have a platform that can address both in the most efficient way, versus having to buy one type of storage for one approach to desktop virtualization and another, SSDs for one and SAN or all flash array or whatever may be the case. So, and we can deliver this all in software from a single platform. Okay, XenApp is a desktop virtualization use case, but it's actually running on a server that's separated out to all the desktops. It has a lot of risk. It's been around for a long time. Virtualizing it introduces new risk. Upgrading to new versions of operating systems adds additional I/O, which then breaks a lot of the existing models for XenApp. So we've worked a lot on reducing and running PVS write caches, as well as running full clone XenApp in memory, which eliminates all of that problem, or even using any SAN for XenApp implementation. And then, of course, performance. This is an interesting chart from Kelway, which is both a customer and one of the larger resellers in UK. After they implemented Atlantis in memory, they were previously running on a SAN. Their help desk calls reduced by 70% because they were all from frozen sessions and profile issues that were related to I/O. So it gives you an idea of the impact when you implement it in a XenApp scenario. Okay. Another thing that we've done, Bernard referenced this, is we've built over years reference implementations, reference architectures with all of the leading manufacturers and done certifications. The vSAN, I think you got in your packet, that was a one where we've both extended vSAN, and Chetan has a slide on this, how we did that. Extended it to pool it with shared storage as well as accelerate it. So that's been published with VMware. We've done significant reference architectures and are co-selling with NetApp, both based on their all-flash arrays and their FAS array. Cisco UCS, we've probably done 10 reference architectures with Cisco going back to 2010. HP3PAR, we have a whole series of solutions around persistent stateless and XenApp with IBM. And then we just published one with Dell. And we've gone through, many, many certifications. Okay, so let's talk about Atlantis ILIO USX. I'll do a time check. Don't want to take away from your demo time. So in terms of what does it do? First, it allows you to do more with existing storage. And this is somewhat unique. A lot of the models where people are talking about doing software-defined storage are either limited to a hypervisor, limited to a certain storage ecosystem, have a lot of limitations. This is allowing you to take what you already have and do more with that. So, for example, you might be able to run 5 times more VMs on the same underlying number of terabytes of storage. Boost performance. So you could take lower tiers of storage and make it run like high-end, more expensive tiers of storage by pooling, aggregating, and optimizing it at the compute layer. Flexibility. So a lot of the times we'll talk a little bit about silos and the fact that you have capacity and performance locked up in different parts of the data center. We actually allow you to unlock that, give you more flexibility about how you present that to applications. And then building a hyper-converged system. So there's a lot of talk about hyper-converged. A lot of people sell appliances that involve ripping out and replacing your existing server infrastructure. We can take software with your existing servers and build a hyper-converged system from that. So the net effect is you can take your existing SAN and NAS and you can get more logical capacity and I/O and throughput out of what's already there, which then extends you and allows you to grow at a much more efficient rate and address that demand for doubling your data center storage every 2 years. Okay, now there are other kind of benefits from this. One is you can build and pool anything across the whole data center. You can provision things much faster. So if you're able to provision VMs very quickly, but then you have to wait for the storage volume, your net effect is your application takes longer to provision. So we can solve that problem. And then we can automate a lot of the deployment. And Toby later is going to show you some of our REST APIs. And we do a lot with larger customers, especially a lot of scripting, a lot of automation work. Okay, so just let's talk about what's the underlying problem. Why is a physical data center so inefficient? The main problem is that you have separated your storage into silos. So there's a tier 1 SAN, there's a NAS, there's an all-flash array, and many different types of DAS. On SAN and NAS that are disk-based, you have to over-provision all of your capacity to get enough I/O for your applications, and you end up wasting tremendous amounts of capacity. In VDI, you generally waste 90% of your capacity because you're trying to get IOPS by adding disk, right? All flash arrays are the exact opposite. They have tremendous numbers of IOPS, but you can't use them because they don't have enough capacity to support the application. And then on DAS, it's kind of universally underutilized because you don't have enough high availability, enough redundancy built into DAS so that you can use it for any application. So because of all this, all of the gray in each of those pie charts is wasting of resources that's because of this silo problem. So what are we doing? We're basically inserting this layer. We're exposing different types of storage up to the application layer. We're optimizing all of the I/O as it passes through us. And then we're taking all of the underlying resource and making that one pool of resource that you can use. Now we separate it we think about it in terms of capacity and performance of the pools. Now we're not only giving you the ability to pool them, but we're actually increasing the total size of each of those pies to be greater than the sum of the underlying parts. Okay, so that, for me, that's it. I'll reiterate, award-winning solutions. The technology and the platform has been proven in hundreds of mission-critical environments, so it's not new. The core of USX and the optimization has been around for years. The ability to expose that and capitalize in it in a software-defined storage way is what's new in USX. And the key is that we're allowing customers to do more with their existing storage and not requiring them to do anything new and change how they operate.